Hello. Today we are demonstrating a cybersecurity attack on water treatment systems using HO scale models. We'll be showing you how a PLC, programmable logic controller, can be vulnerable to cyber threats. Let's first give a basic overview of water treatment plants. In its simplest form, these plants perform a vital function. They treat water to remove harmful contaminants and ensure it's safe for us to use and consume. The water treatment plant have advanced systems based on PLC, smart meters and chlorine sensors that work together to meet the system objectives. The PLC is the heart of the operation. It takes in data from the chlorine sensor and makes decisions based on the data. If the chlorine level is appropriate, the PLC instructs the pump to release the treated water. But what happens when hackers get involved? Cyber threats can penetrate this system, causing severe damage and even a public health crisis. Imagine this. A hacker gains access to the water treatment plant's network, possibly by exploiting weak or shared login credentials or outdated software. This hacker then navigates to the PLC. With access to the PLC, the hacker could manipulate the data from the chlorine sensor. For example, they could trick the PLC into believing the chlorine level is acceptable when it's not. The PLC, acting on false information, would then instruct the pump to release untreated or harmful water. To create this on the Cyberange physical lab, we first design a water treatment plant based on real-world architecture. This small-scale water treatment plant we have here includes a pump controlled by a Siemens S7-1200 PLC, a smart water meter, and a simulated chlorine sensor. The IT systems that control this plant include an Active Directory-based Windows environment along with a web application and a mail server. The target of the participants who work on this challenge will include the following. Step 1. Send a phishing mail to the employees of the water treatment plant. The initial recon can be done on Facebook or LinkedIn along with other open-source intelligence techniques. Step 2. Target the web application of the company, elevate the privileges of the user and gain access to the Active Directory domain controller. Step 3. Do lateral movement to find HMI dashboard systems or inject a ransomware to conduct a site-wide crippling attack. This ransomware attack is executed using the AttackWiz platform provided by Cyberange. The AttackWiz platform automates the MITRE attack framework and acts like a red team professional to target systems. Step 4. Once you access the HMI dashboards, you can execute your final attack. As the model must demonstrate a cause and effect impact, you can try turning the water treatment facility on or off and see the filtration motors getting impacted. Step 5. You can disable the chlorine sensor or you can contaminate the data that is fed to the PLC. Or you can program the device using ladder logic to allow release of untreated water into the residential complexes. Typically, on the model, when the untreated water is released, the warning system's or alarm systems must be triggered to prevent this. Visually, you can see the LED lights flash red or green depending on the status, and you can also program an alarm to trigger a siren for making a sound. When the systems are compromised, the LED lights or the siren do not work as intended, indicating a successful hack. So what are the outcomes of this activity? Participants learn many skills, such as how to create phishing mails, conduct social engineering attacks, conduct open-source intelligence against a target, evade local endpoint detection systems, execute a ransomware attack, or even do lateral movement to find interesting systems. Finally, the candidates learn how they can impact the critical sector, remotely, causing immense economic and reputation damage. Every scenario typically has 5 to 7 additional levels of hacking challenges before they can reach the OT systems. The skills require that candidates exploit a combination of IT and OT systems to meet their objectives. To summarize, the following devices are involved in this scenario: Active Directory, Windows Domain Controller, a vulnerable web application, mail server, Siemens PLC, HMI dashboard, industrial sensors, alarm systems, LEDs, motors to simulate the filtration process, water pumps, water tanks under the physical table, AttackWiz platform with thousands of malware samples, including real ransomware files, exploits that can be used via Metasploit or the AttackWiz tool, cabling to connect the IT and OT systems, internet connectivity over LAN or Wi-Fi to the OT systems, and various Python scripts to help simulate the entire effect. You can upload your own programs and change the attack process. The entire virtual labs platform provided by Cyberange is on the lightweight and efficient Docker systems, powered by Kubernetes. You can also design your own physical lab scenarios by engaging with the Cyberange team. The physical model has over 10 critical sectors and 100+ challenges out of the box to train professionals in cybersecurity for business. New scenarios are added frequently to enable you to practice the latest attack vectors impacting the industrial sector. The immersive learning experience in the innovative platform provided by Cyberange not only elevates the status of your labs but also brings immense brand recognition to your organization. Thank you and happy learning.